Okay, now that we have learned about everything in chapter 1, let's do the revision by completing these PDF notes, okay? You can now either download it or print it out. As long as you can do that, it will help with your revision. Because just looking through the video, you may not grasp the spelling and the terms very good, okay? So first of all, in each chapters of this kind of notes, we have this section telling you a lot of vocabulary that we have to use, and sometimes I will highlight these for you to have a focus, have to study, because this kind of spelling sometimes you will mix up and get it wrong, okay? For example, Celsius temperature scale, thermometer, temperature sensor, and calibration. These kind of words sometimes we spell wrong, okay? And for the fill in the blanks, we are going to go through it together. And for 1, 2, 3, 4, 5, its main focus is in the Celsius temperature scale. Since there are many ways we can measure different units for temperature, but we are learning about Celsius, and let's have a look, okay? For number 1, our sensors are not reliable for comparing hotness and coldness. This is not reliable. Then what is reliable and scientific? The appropriate instrument to measure their temperature. Okay, temperature is the scientific unit that we are after. Okay, and what is the scale we just mentioned? It is the Celsius temperature scale. Capital letter. Okay, I think the pen is too thick. Celsius, S-I-U-S, temperature scale. 2, 3 words. Okay. It is a most commonly used international temperature scale. Its unit is degree Celsius because each degree Celsius. Oh, sorry, capital letter C. And the symbol is like this. Okay, very good. Number 3, temperature scales are usually defined by choosing how many fixed points? 2 fixed points. And what are they called? They are called the upper fixed point and the lower fixed point. Okay, question 4. There are 2 fixed points, and what are their names that we are after in the first blank? The first one, it is using pure melting ice, so it is of course the ice points here. And then it is chosen as, because we use 2 fixed points, this one lower temperature, we call it the lower fixed point, okay? This is taken as 0 degrees Celsius. And so the other is called the steam point. The temperature of steam point is taken to be the upper fixed point and 100 degrees Celsius. Okay, this you might think it is a common sense, but the terms, how we call them, is the main point here. You have to remember. Okay, and the instrument we use to measure the temperature, of course, is the thermometer. Thermometer. Okay, so these are the answer for the first 5 questions. I will let you have a look here and pause if you have to copy. And then we go to the next part. Okay, 2 common types of thermometer using in the laboratory are, this kind is called liquid in glass. There are 2 main types. You can use alcohol or mercury. They are liquid in gas thermometer. And the other one, this one, is called the temperature sensor. Very straightforward. Temperature sensor. Okay, before temperature can be read from a thermometer conveniently, we have to make sure that they are collaborating with the standard. Okay, this action is called calibration. 校準. Okay, and to calibrate, the thermometer in Celsius temperature scale, the ice point and the steam point have to be reproduced first. But how do we do that? Okay, ice point and steam point. We do that by putting in melting ice. Melting is very important, and boiling water. They have to be at the state where the state is changing, so we can tell for sure it is at the right temperature. Okay, the liquid level in each case is marked, and the separation between the two marking is divided into 100 equal divisions, and each represent 1 degree Celsius. Okay. Since metal have very high boiling point, they can measure very high temperature. How high, you ask? Up to several hundreds, 357 actually. And for alcohol, it is good for measuring a low temperature. It can be very cold, even negative 115 degrees Celsius. So they are good for different occasions, right? And for mercury, it has very quick response, and the alcohol will have slow response. This side, mercury wins. Okay. However, mercury is poisonous, while alcohol is more safe. It is not poisonous. And for this part, fill in the blanks. You can handle that. In this part, we are going to learn about different types of thermometer. So far, we only focus on this type, but there are infrared ones that the metal will bend one, resistant one, color changing one. Okay, a lot of different types of thermometer. But what are we going to learn about them? There are 3 things. Okay, first, what's your name? How do we call the thermometer? Okay, the second one is, what does it measure? What is the physical properties that will change with the temperature? When it is hot, this property will change. For example, in the liquid in glass, what is the changing part? It is the volume. Okay, but not all is using the volume change. For example, infrared, it is how much infrared you give out. Okay, so the second thing we want to learn about a thermometer is the temperature dependent property. What is the property that change with the temperature? And the third thing is the application. After we know how the thermometer works, we want to know where in daily life, in real life, will we make use of this type of thermometer. Okay, let's start. Start with the one we are most familiar with, and it is the liquid in glass thermometer, the name you know. And we measure the properties is the volume. And when we talk about the volume, we also want to know how its relationship is with the temperature. When the temperature increase, the volume also increase. This is positively proportional. Okay. And then application, there are several ones. First of all, the temperature of human body, of course. And we can use in the weather recording to tell, okay, what is the temperature right now in the environment. And also in laboratory is also very common. Laboratory. Okay. And the second type of thermometer we are covering is this IR thermometer. That is infrared. It measures the infrared radiation that you emit. Maybe you have seen some videos or demonstration where the human body whole picture is shown, and the hotter part is red or orange, and the colder part is blue or green or other color. And those technology making use of a fact that when something is hot, it will give out more infrared radiation. Okay, so it is very fast, and it is very good measure to use as a human body temperature measuring. Human body again. And the relationship is when temperature increase, the IR emitted also increase. Okay. And the third bit is more related to cooking, because the application, you may have seen some thermometer looking like this in oven or freezers. Okay. How does it work? This type of thermometer called rotary. It will rotate when the thermometer feel the change in temperature. But why does it rotate? Is because the curvature of bimetallic strip. What does it mean? Bimetallic strip. It is coming from two parts. Bi means two. Metallics is talking about the metal, 金屬. Okay, in this part, the illustration drawn here, let's say in low temperature, there is these two type of metal. They are both 10 cm. Okay, but when the temperature increase, they have different level of expansion. For example, the upper one from 10 to 11, but the lower one from 10 to 12. Okay, so when the two things is fixed together at the beginning and the end, when this one want to expand longer, but this one doesn't expand as much, so the result is it will twist due to this difference in the level of expansion. What we call is the bimetallic strip, and the curvature increase with the temperature. Okay, application is ovens and freezers. Next, resistance thermometer. And by the name, you can already tell what is the physical properties we are making use of. It is the resistance of a metal coil. That is 電阻. You have learned that in Form 2 already. And the relationship between them is they will increase together. When it is hot, the resistance increase. So based on the relationship, the measurement, we can tell how hot it is. And the application is oven and car engine. Okay, ovens and car engine. Wrong spelling. Okay, much better. And the next one, thermistor. Well, inside this table, this is the first time we have when the temperature increase, the resistance will decrease. However, it is very similar to the above. It is using the resistance as the temperature dependent variable. And the application is in human body and electrical appliances. Electrical appliances. Okay, and the last one is this type of color crystal. When you stick it here, depends on the temperature of your forehead, the color of the crystal will change. So the temperature dependent is color. Temperature dependent properties is color. And of course, it is human body. And another use is fish tank. You just stick it in the fish tank, and it is very convenient to tell whether it have to be hotter or colder. Okay, so have a look again in case you have not copied it down already. So you have to know the name, the temperature dependent property, and the application of these few thermometer. Okay, next slide here, smaller. Pause the video if you need. And the last part like this. Okay,